Steel Ball Run is fantastic. While I enjoyed Part 5 being animated, nothing will surpass my affinity for a good Western. And no Western, no matter how crazy, can be complete without some type of standoff. So we have probably the greatest standoff in the history of standoffs. The President of the United States versus a famous English jockey. The Infinite Rotation. Before we tackle Tusk Act 4, we must understand what the spin, or chitin, is. We can do this by understanding how it differs from regular spinning objects. And we've already covered typical rotational energy in the Stand Science on Sex Pistols, so I won't go into too much detail here, but the key concept you have to remember is that standard linear physics has many equations that are similar in rotational calculations. While translational kinetic energy is 1/2 mv squared, rotational kinetic energy is 1/2 I omega squared. So the technique known as the spin has many properties that make it one of the most unique abilities Araki's ever written. For general purposes, it enhances projectiles, hardens skin, and creates large amount of friction. But the Zappelli family from Naples, Italy, managed to go even further beyond. And fun fact, my bloodline actually descends from Naples, so without a shadow of a doubt, I have some Zappelli in me. They were able to refine the spin to a state which it could trigger muscle reflexes, flatten limbs, wring water out of the body, shave hair, and most importantly, bring clean, painless death. And it just so happened in the Middle Ages, horsemen developed a new method to bypass armor and shields of knights. Using stirrups, the rotational energy of the horse was harnessed to reverberate throughout a rider's entire body and ascend the spin to an incredibly powerful super spin. If I ever do a ball breaker Stand Science, I'll go more into detail about this, but for now, this is all the background we need to know. What makes the super spin different than the regular spin besides being more powerful? Well, the best way I could describe it is the same way Funny Valentine described it. Energy that can cross dimensional walls. The infinite rotation is a consequence of the super spin. Before we actually determine what kind of force could possibly cross dimensions, we must consider how Tusk Act 4 came to be. Once the infinite rotation is used, a target's body begins to spin itself apart and drags it downward spiral, as stated from the informational panel about Tusk Act 4. With the rotation of the horse's running power, combined with Johnny's Tusk's rotation, a stand ability with the power of the infinite rotational energy. In order to control gravity, that rotation pierces through other dimensions. Its damage is also likely infinite and should never end. So is it the most powerful stand? Oh, I think it could easily be as strong as Superfly. So canonically, Tusk is a gravity-related ability. But this is very different than like Echo's Act 3 or Hmmmmm. Tusk's gravity is something more specific. It has to be something that has so much gravity that it spins infinitely, like a black hole. But more specifically, we're just gonna look at gravity wells. So what is a gravity well? I think a physical representation is probably best. So imagine this garbage bag is your flat space-time, and any celestial body, a planet, an asteroid, a star, will bend it. Now here I have a gyro ball, an apple, and an orange. An apple hit Isaac Newton in the head and he thought of gravity, but I like Naranjas better than apples, so we're gonna use the orange as our star. So when I place the orange down, you see that it begins to bend the bag. So if you roll the gyro ball towards it, it's gonna orbit a little bit, and that's how planets orbit around the sun. Now, since our budget demo's over, real engineers have created better representations of gravity wells out of metal or ceramic. So gravity wells follow the equation y is equal to c over absolute value x, where the constant c is negative big G times your mass. In a gravity well, there's no friction, so no energy is lost to friction. On the physical models, we're assuming they follow the small angle approximation, where if an angle is so close to zero but not actually zero, we treat it like zero. So cosine of that angle will be approximately 1, while sine and tangent of that angle are approximately the angle itself, thus confirming no energy is lost.
Gravity. Gravity is a harness. My entire career has been devoted to this idea, to this moment. Decades. If the unifying theories are correct, we will soon be able to harness the power of a black hole. What is that melody?
what brought about the infinite rotation for Johnny was being kicked by his horse, Slow Dancer. Horses on average run at about 55 miles per hour or 24.587 meters per second. However, we have to consider that this is the average speed of horses today. You know, I never thought I'd be reading a research paper about how horses run for stand signs, but apparently I am. So, because of selective breeding, the average speed of horses has increased 0.11% every year. This recent paper from the Royal Society in 2015 details that change. So all we need to do is, what's the reverse of extrapolate? Interpolate. To interpolate, I wrote a Python script that does that for me by creating an array for the current speed of a horse and the years between 1890 to 2015, which is 125 years. We can go step by step backwards 0.11% each year, since 0.11% one year might be different than 0.11% another year. So that change is actually not constant per year. This will give us a speed of 21.43 meters per second in the year 1890, shown by this graph, which is a pretty linear relationship. Obviously, the horse's power alone can't reach infinity, but it's not only the horse working in this scenario. Johnny's flavor of the spin is almost completely offensive, except for the evasive ability of Act 3. As demonstrated in many fights, Johnny's finger and toenails provide sufficient rotational kinetic energy to be fired as bullets. Using a single nail bullet, the help of Zeppeli's steel balls, and Slow Dancer, Johnny's able to unlock the power of infinity. Using conservation of energy, the energy of the horse's kick is equal to the energy that Johnny is spinning at, plus the energy that Johnny travels at through the air after being kicked. I'm gonna be really bad, but for the purpose of this video, I'm gonna model Johnny as a sphere because Johnny is dummy thick. And come on, that little crumpled up pose kind of looks like a sphere.
A perfect circle! Do it again. Show your process.
Well, first I draw this head, then I erased some of the more detailed features, and 1, 2, 3, a circle thingy.
So a paper about the trends in heights and weight since 1885 puts Johnny at about 64.468 kilograms. As we said before, rotational kinetic energy is 1/2 I omega squared, and the moment of inertia of a sphere is 2/5 mr squared. Assuming Johnny's below average height is about 5'7" or 170 centimeters, then his radius would be 0.85 meters, making his moment of inertia I 18.63 kilograms meters squared. To initiate Tusk's final form, Johnny is launched like a projectile motion problem you would probably tackle in high school physics. So using this perspective panel, we can guesstimate that Johnny's height when he's kicked is about 1.63 meters, which is just about the height of the horse, Slow Dancer. The average weight of an Appalachia horse of this size is 431.27 kilograms. Using one of the fundamental kinematic equations, final velocity squared is equal to initial velocity squared plus 2AD, we can figure out the initial velocity, assuming that D is our height, A is the acceleration due to gravity of the Earth at 9.81 meters per second squared, and the final velocity at the highest point is 0. This gives us an initial velocity in the y direction of 5.655 meters per second. Now Johnny's launched at about a 45-degree angle, so using basic trigonometry, we know that sine, or the opposite over the hypotenuse of this triangle, of 45 degrees is 1 over the square root of 2. So rearranging the velocity in the y direction equal to the velocity times sine of that angle, we can find out that the translational velocity for Johnny in this situation is 7.99 meters per second. Finally, we can put this all into the conservation of energy equation. As I said before, the kinetic energy of the horse is equal to the kinetic energy of Johnny moving plus the kinetic energy of Johnny spinning. The one variable we don't know, which is what we're searching for, is omega, the rotational velocity in radians per second. By plugging all these numbers in, we can solve for omega to be 102.056 radians per second, which is about the speed of a slow drill, which seems pretty reasonable. Now, we only want the rotational energy of Johnny spinning because that's all the energy that's going to be transferred into Funny Valentine to begin the infinite rotation. Plugging that value back into just the rotational part gives us 96,919.8 joules, a fearsome phenomenon. The infinite rotation of the steel ball. Is it the maxim of nature or a forgotten piece of human wisdom? Chris.
Chucky.
That was very interesting.
Science.
So that's it. That's the amount of initial energy you need to start an infinite rotation. And no one can help you to get out of it. Well, unless you're alternate universe Speedwagon. Thank you so much for watching. This is the start of Season 2 of Stand Science. I want to include more demonstrations and coding to solve these problems in the future, so that's why it took so long. Let me know what you think in the comments below. Have a beautiful Duang, and I'll see you all next time.